recording on this now.
V.
Recording. Hello, year 12, soon to be year 13. Nice to see you. No, nice to talk to you. I'm trying something new today, so you're hopefully going to be able to see the screen, and you're going to hopefully be able to hear my voice, and you're going to be able to see me as well. So it's a combination of all three. I'll make sure that the video of me is the smallest because you don't want to see my face today.
So you're gonna be like there.
Yeah, exactly.
And then you can do it to mine, and then I can record Minecraft videos. Then I'll get £1 million.
Right. So let me just quickly talk to my class because I don't want to keep you too long. Right. This next task jumps back a little bit because I've jumped straight into NMR, but I've had a few emails off you saying that some of you don't feel comfortable with infrared and some of you don't feel comfortable with mass spectrometry, and these past paper questions combine all three, so I want to make sure you're really comfortable with infrared and really comfortable with mass spec. Now, we know a bit about mass spec, but we don't really know much about the fragment patterns, so I'm going to talk about that in a second. And infrared, well, some of you said, what's it about? It's a very, very simple thing. We're just using the data booklet, really. So, looking at the PowerPoint, you're going to be learning about how compounds are identified using infrared, and then I've combined a bit of mass spec with it. So, first of all, let's just quickly talk about mass spec. Now, mass spec, one of the key bits of information you get with mass spec is you get something called the molecular ion. And this molecular ion peak actually tells you the MR of your molecule. Now, if you know the MR of your molecule and you know the empirical formula of your molecule, you can actually work out the molecular formula, which is what we need to become experts at. And that is what will be on the past paper questions at the end as well. So, molecular ion peak is the furthest peak to the right. And then the other fragments you can work out. For example, a fragment of 15 is probably going to be CH3. A fragment of 16, if you had oxygen, would probably just be oxygen. A fragment of 17 would probably be oxygen and hydrogen, and so on. So these are the fragmentation patterns. Have a go at some of these activities on here today. Then, I want us to quickly look at spectroscopy, as in infrared spectroscopy. Infrared spectroscopy is used to identify unknowns. Now, what I've shown here is, if I go back here, if we had ethanol, you can oxidize ethanol to become an aldehyde, which would be ethanal, and then if you oxidize that further, it becomes ethanoic acid. But each and every one of them are colorless liquids. So how can you tell the difference between them? What would you do, Emmett?
Drink them.
No, drinking chemicals is the worst thing you can do, actually, because they probably will kill you. So what you need to do is test them, and this is where infrared spectroscopy comes in. Now, if we look at infrared spectroscopy, what happens, and the technique itself you don't really need to be an expert on, you just need to be thinking about, well, actually, they send out a load of infrared waves. Every now and again it hits the molecule, and when it hits that certain wave number, keep that down, when it hits the certain wave number, the energy is absorbed, and you get something like an OH stretch. So if there was a molecule with an OH in there, such as water, such as an alcohol, you get this OH absorption, and that's what you see. And it's a big old, wide kind of absorption trough, I guess. It is a trough, yeah. And then you get something like the fingerprint region. Now, I can't record the other bit, but cross-reference this to your data book, and you'll be able to see. So, for example, there, this big trough here at 3,400, that tells me it's OH. Now, what I want you to do in this task is go through some of these and see if you can work out what functional groups are present. It cannot, and it will not tell you the whole molecule. You need to use the MR, the molecular mass. You need to use the infrared, and you need to use the NMR to work it out. And also, your MR fragments. Sorry, your mass spec fragments as well. So there's some bits to work through here, and I'll make sure that the PowerPoint's all nice and clear. Also, at the end then, I've got some past paper questions for you with the mark schemes attached, and then I've gone into the 2016 paper for you to have a go at using carbon NMR, functional group tests such as adding bromine across a double bond, and if it's kind of 1 mole to 1 mole, there's only one double bond. If there's two moles of the bromine to the 2 moles of bromine add to your molecule, 1 mole of your molecule, then there's 2 double bonds and so on. But there's not hydrogen NMR. Now I'm very aware that some of you need a bit more help with hydrogen NMR, so I will make another video on there. So work through this. Again, let me know if you're struggling with anything. Just follow the PowerPoint on and on. Use things if you are struggling. The important thing about going into year 13 is to kind of read around the topic. So use things like the textbook. Use things like my Chem Guy YouTube videos, because he goes into detail on very, very small bits. But hopefully this will make all clear, and I'll post another video with me answering these questions to model the answers. So look forward to seeing you soon. Bye. Now if we stop this as well.